All right, welcome to Chapter 1, Section 5, using the distributive property. So just as always, I'll go over a couple of features on the screen here. The first thing you're going to see is the due date. I don't see that on the teacher preview, but you'll see it on your side as a student. The second thing you'll see are the number of attempts. You always have unlimited attempts, meaning you can come in and complete the assignment as many times as you would like. That's true of homework, tests, and quizzes. Number of questions just depends on the section. This particular one has 9. Grading policy is best score, so whichever attempt is the best one is the one you keep. And partial credit is enabled, so if you answer one of 9 questions correctly, you get credit for the one question, or however many you answered correctly. Down here it says once you start your homework, you must finish it before you can work on anything else. What that means is once I click start, down in the bottom right corner here, there is going to be a submit assignment button. I need to make sure that I click that submit assignment button as soon as I want to leave this screen. Whether or not I've started any problems or if I've just done a couple of them or maybe I've done them all, click that button. It does 2 things. Number 1, it stops the system from locking you out, just like that last screen said. It's going to assume that you want to come back to this assignment if you don't click submit assignment button. Remember, you have unlimited retakes. You can come back in as many times as you would like, and it saves your place. So as long as you have a green check mark up here and you've completed the problem, it's going to save that and come back to that, or it's not going to make you repeat it. The other thing that it does when you click the submit assignment button is it actually goes into the grade book so we can see what you've done. Until you click that button, it's kind of just being paused. We don't get to see any of it. So make sure always click that button. On the side here we have explanation, example, and message center. So explanation tells you you're going to lose your question attempt because it's going to give you the solution to this question right here. And it's not going to give you the answer and then let you come type it in. Example shows you an example of the same problem type of what we're going to do. So a lot of what we're going to do today is kind of factoring, which means we're going to be dividing away the greatest common factor for pieces. So we're undistributing things in a way. It's still the distributive property, but it's kind of the backwards of actually distributing. We're factoring it back out. And then you can also message your teacher directly from this screen. It attaches a picture, so hey, we know where to come help you. All right, so now let's go ahead and take a look at the problem here. So it says factor 8x minus 24. So 8x minus 24, and just like that example was saying, is we need the greatest common factor, not greatest common multiple, greatest common factor. So I want to know what's the biggest number that can divide into both 8 and 24. Well, that would be 8, wouldn't it? 8 can divide into itself, 8 can divide into 24. So 8 divided by 8, and what I want to do is I want to take that greatest common factor and put it out in the front. So actually I'm going to change the color here. I'm going to make it blue. Why not? So there's my greatest common factor, and I'm going to take it out. I'm going to divide it away from each one. 8x divided by 8 is just x, because 8 divided by 8 is 1. Negative 24 divided by 8 is negative 3. So this is what it originally looked like. And we spent a couple of sections distributing these pieces where we'd say 8 times x, 8 times negative 3. Now we're just going backwards. We're taking it back out. We're factoring it away. So it means we're dividing it away instead of multiplying it in. So that's all. We just want to make sure that we find the greatest common factor and divide it out. And check. All right, next. So find the greatest common factor of 20n and 15n cubed. So with this one, you want to find the greatest common factor of 20 and 15. So the greatest common factor, the biggest number that can divide in both 20 and 15 would be 5, right? 20 can divide by 5 and 15 can divide by 5. They both can't divide by anything bigger than that. And then we also have the greatest common factor of n and n cubed. So when we're doing the variables, we need to be careful about this because you can't take more than is available. So I can't divide away more than the smallest amount. That's kind of the trick there, is whichever one is the smallest one is the greatest common factor. Because there's 1 n here, there's 3 here, but I only have 1 to divide away. So the greatest common factor of n and n cubed is n. So together I get 5n, like that. So I just need to look at them kind of separately and then put them back together because I can take out both a coefficient of 5 and a variable of n from both. So it's a greatest common factor for both. Alrighty. So now they're getting a little bit more complicated here. So we have 24 and 18. So I just focus on the coefficients first because we're going to do the greatest common factor. So it says find the greatest common factor of these two expressions. So it's not asking me to factor it. It's just asking me to find the greatest common factor. So again, just, be careful. Make sure you're reading the directions. So 24 and 18, the GCF, greatest common factor for 24 and 18, let's see. This can divide by 6, and this can divide by 6, and I think that's the biggest thing that they can both divide by, is 6. Because otherwise this would be 9, this would be 8, but it has to be the same factor. Alright, so then we also have, we have a W here, but W it's the only W here, so there is no greatest common factor, because 24 doesn't have a W on it. So they both have to have it in order for it to be a greatest common factor. So keep that in mind. So I can't take a W. But they both do have an X. So I have X to the 8th and X to the 5th. So remember, the greatest common factor when I'm looking at a variable is just the smallest one. So the smallest one here is X to the 5th. I can divide X to the 5th away from both of these. That means this one would cancel out and this one would become 3. Because I subtract those when I divide them away. Alright, and the last one, they both have a U. So U to the 6th and U to the 4th. So same thing, greatest common factor is going to be the smallest exponent there. So U to the 4th. Because they both have 4 that I can take. So total, I just put them back together here. My greatest common factor is 6, X to the 5th, U to the 4th. 6, and be careful when you're typing this in because you do need to make sure that you're putting in exponents, and also be careful about how the way you type, because if you don't click the exponent, number one, it just starts writing it like that. But if I don't click out of the exponent, like if I wanted to keep writing something and I didn't click out, it keeps writing up there in that exponent. So make sure you have to click the over arrow to come out, or you can use your mouse to kind of click down here, just kind of bring yourself out of the exponent. Alright, let's go ahead and erase all this stuff. Get myself a little bit more room here. Alright, we'll go with red again. Alright, so now it's actually asking me to factor it. I still have to find the greatest common factor of 4 and 10. So the GCF of 4 and 10 is going to be 2. They can both divide by 2, but nothing bigger. 4 can divide by 4, but 10 can't divide by 4. So now I have the greatest common factor of y cubed and y squared. So the GCF for these guys is going to be that smallest one here, because I can take y cubed from both. So my greatest common factor is 2y squared. And I'm going to divide that away from both pieces. So when I divide 4 by 2, I get 2. When I divide y cubed by y squared, remember that means we subtract. 3 minus 2 leaves me with just 1y. Plus 10 divided by 2 is 5. And then y squared divided by y squared, well, 2 minus 2 is 0. Anything to the 0 power is 1, so that means I don't have any y's left. So this is factored. So identifying those greatest common factors, it might take a second to write it out, but definitely helps you understand, this is the greatest of the pieces that we can pull out, or of the terms that we can take out of them or divide away from them, I guess is the best way to say that. Okay. Oh, that is the next one. Okay, so we have 16 and 28. So 16 and 28, and we're factoring again. It's actually an expression, so we're going to factor it. It's not just saying find the greatest common factor, but we still need to find it. So greatest common factor of the coefficients here is, let's see, 16. This can divide by 8, but 28 can't divide by 8. 16 can divide by 4, and 28 can divide by 4. Let's see, I think that might be it. Yep, 4. Because if I divide by 4, I get 4. If I divide by 4, I get 7. So I'll put that guy in blue for whatever reason, because I keep doing that. Blue. All right. So now I have w and w to the 8th power. So the GCF is going to be the smallest one, because that's all I can take. It's all that's available from both. Then I have x to the 4th and x to the 6th. So again, the GCF is going to be the smallest, which is x to the 4th. And then this also has a y, but only the 16 has the y to the 7th. So I can't take it at all. It has to be left behind. All right, so the GCF is going to be 4wx to the 4th power. And then we're going to divide it away from each piece. So, and I can even do it from right here because I wrote most of the pieces. The one I do need to remember is y to the 7th because I didn't write that over here on my other screen. So 16 divided by 4 is 4. W divided by w, well, that cancels. Any number divided by itself is 1. X to the 4th divided by x to the 4th also cancels out because any number divided by itself is 1. So I'm left with just that y to the 7th. Minus 28 divided by 4 is 7. And w to the 8th divided by w, remember there's a 1 here. So that means 8 minus 1, which gives me 7. X to the 6th divided by x to the 4th, 6 minus 4 is 2. So remember, when you're dividing variables with exponents, as long as it's the same variable, you subtract the exponents. When we multiply variables with exponents, we add the exponents. So multiplication, addition, division, subtraction. So just kind of a review of that. Let's see. 4wx to the 4th power and 4y to the 7th power. I was almost going to type that funny. Minus 7w 7. The longest thing is just typing this in the right way, making sure I'm not messing up these variables and these exponents. All right, I hope I didn't miss anything there. Please check that oops, see, I left the parenthesis up there. They didn't like that. There we go. Check. All right. So, erase some more of this stuff. Okay, so we're going to, it says factor by grouping. So this is a little different. When we have 3 terms, we factor a little bit differently, or when we have 2 or 3 terms, we can factor a little differently. Sometimes you can take the same number or the greatest common factor out of all of these, but if you notice 3, 4, 21, 28, they all don't divide by the same thing. 3 and 21 can both divide by 3, 4 and 28 can both divide by 4, but they all can't divide by the same number. And they all don't have a v. 28 does not have a v, so there is no greatest common factor for all of these terms. Doesn't mean we're stuck. What it means is we do what's called factor by grouping, like what they're saying. So when we do factor by grouping, what we want to do, and I'm just going to write this out, plus 28, we want to basically create 2 groups. So I'm going to group the first 2, and I'm going to group the second 2, like this. And be careful about this piece here. If this was a minus sign, make sure it gets grouped with this number, and it's a plus out here. Because otherwise, you have to take the negative out of everything. Kind of is a pain. But make sure you're paying attention to that. Since it's a plus sign, not a big deal, because it's still positive here. All right, so now from each group, and I just noticed, I don't know why that was still blue when I wrote it. From each group, we're going to factor out the greatest common factor for each piece. So the GCF for 3v squared and 4v squared is simply just the v squared. That's the only thing they share. So the greatest common factor here is going to be v squared. Okay? And then the greatest common factor over here, because we're going to do this group separately, is, and I'll go with green here, so 21 and 28, let's see, can they both divide by the same numbers? Ooh, they can both divide by 7, can't they? 21 divided by 7 is 3, 28 divided by 7 is 4. So they can both divide by 7. They both don't have a v, so 7 is it. That's the only thing I can factor away. So now I'm going to go here, now that I have my my greatest common factor. So 3v squared divided by v squared just kind of cancels that away, doesn't it? V squared divided by v squared, it leaves the 3. Plus 4v squared. This is interesting. It's gonna, oh, that's a cube, that's why. I was gonna say, that doesn't make sense, so we're left with 1v there. That makes more sense. I'll write that a little nicer, I guess. So we're left with 1v there. And then 4v squared, that's where the v's cancel out. I was going to say, wait, we're going to end up with 3 and 4, and we're going to combine those. That's not right. What I wanted to end up with. Plus, so now we're going to take the 7 out of this group here. We're going to divide it away. So 21v divided by 7 is 3v. Ooh, do you see it's matching already? This is actually what we want with grouping, is we want something to be matching at the end. 28 divided by 7 is 4. So if you notice, we have these guys matching, 3v plus 4, 3v plus 4. And what we actually are going to do is we're going to factor that out again. So factor by grouping, we group it and we factor each group. So we've already factored basically twice here. And then we're going to factor a third time. But this time we're going to take the entire 3v plus 4. So I'm dividing this entire thing away, and I'm going to be left with the pieces. So if I factor away 3v plus 4, I divide it away, I'm left with what's in front here, which was that v squared. Plus, I'm also going to be left with this 7 because I'm going to factor this 3v plus 4 away from this one as well. I'm factoring away from the entire thing. So I know it's a little bit different when we look at it that way because we're kind of looking at it as a bigger piece, and it's this whole binomial that we're factoring out, not just a number or a number and a variable, but the entire thing as a unit together. So this is factored by grouping, and it's especially when we have the 4 terms like that, we can't factor kind of normally like we would with a trinomial. Or just, a binomial where we're taking out just a number. V squared plus 7. Check. All right. So we're going to try that again. Whoopsie. Okay. So we're going to factor by grouping again. So we get to practice this again. So uv plus 3u minus 2v minus 6. And it shouldn't matter how you group them. It's just kind of easy to group the first 2 and then the second 2. Be careful, like I said, when you're grouping the second 2, there's a minus here. Include that minus with the 2. Don't take it away from the 2, because otherwise you're going to have to take that into account right away. What I would do is just put a plus right there. So it's not being multiplied. These are being added together. I just included that negative with the 2 since it belongs to the 2. All right, so the greatest common factor for each group. A little bit less color changing here. All right, blue for the first group. So this one, u and u, so I can take out a u from each. They don't both have a v and they don't both have a coefficient. There's one here, but 1 and 3, the only thing I could take would be 1. So the greatest common factor would be u, or this one. Plus, let's see, we'll do this one, greatest common factor over here. So we have -2 and -6. So the greatest common factor would actually be -2. I can divide -2 away from both of these. And I want to take the negative because these are all positive. Remember, we want to end up with something matching. So I don't want to have all positive and all negative. So I'm kind of planning ahead on that one. I'm going to take the negative with the 2 instead of just doing 2, since they're both negative here. And they don't both have a v, so -2 is all that I can take. All right, so now uv divided by u, well, that cancels out the u, and I have a v. 3u divided by u, that cancels out the u, so I have a 3. Then over here, I'm doing -2v divided by -2, cancels out the -2, and I'm left with a v. -6 divided by -2, Two negatives make a positive when I'm multiplying or dividing. And 6 divided by 2 is 3. So happy day, look at that. We have these matching pieces again. So I'm going to factor that out one more time. And then I'm going to write out what I'm left with here. So I'm left with u. And instead of saying plus -2, I'm just going to say -2 like that. Oh, that was my bright green. I didn't mean to grab the bright green. -2. So, in fact, Alex is not going to like it if you try to type in plus -2. It's going to kind of give you grief about that because it wants you to simplify it. -2. There we go. Check. Next. Okay, so now that we've been practicing factoring, what they're going to have us do is use this factoring to find the solutions of a quadratic formula. And a quadratic, when we have anything squared with the variable squared, we have this shape that goes like this. Woo, that's an ugly arrow. Like this. Or it could very well open down. So this is opening up, this is opening down, but it's going to be some shape like this in a graph. We're not going to have a line like we have before. What we're going to have is called a parabola. And the solution to a parabola, when they're asking you to solve it, is if we have an XY coordinate grid here, and the parabola goes across like this, what it's saying is where does it cross the x-axis? That's actually the solutions. So when we set it equal to 0, what we're saying is, we're finding the zeros, meaning when is it at the x-axis? That's what 0 means. So that's what we're going to do here. They've already factored this guy for us. That was nice. So once we have two factors that equal 0 like this, they're being multiplied together and they equal 0, and I'm going to cross my z's so you don't think they're 2's. What this, there's a theorem here that lets us know that one of these must be 0. If we're multiplying them together, one or both must be 0. That's how we get 0 here. So we make the assumption that they're both equal to 0. We just set them equal to 0 here. And we say, okay, what do we get when they're equal to 0? Like this. So then I just solved them separately. So you notice this one just came down here, this one came over here, and I put them both equal to 0. And so now we're just going to solve for z like we would any other equation. 8 minus 8 cancels. -8 equals, I'm going to divide by 3, divide by 3. Z equals -8 thirds. I'm going to leave it -8 thirds because it doesn't give me any answer or any instructions on rounding, so I don't want to round anything and then get marked off for that. All right. This one I'm just going to subtract 4 from both sides. 4 minus 4 cancels. Z equals -4. So I have -4. So let's see. Check. Yay. Your answer is correct. However, you could also write the answer with the negative sign in front of the fraction. So it's giving me grief because I put the negative up here with the 8. The proper way that it would like me to write it would be this negative right in front, is all that it's saying. All right. So now we get to factor this one first. And we've been practicing this factoring this whole time. So we have 4v squared plus 24v equals 0. So we have 4 and 24. I'll scooch those over a little bit more. So the GCF, geez Louise, getting to the end of the video, getting a little thing here. GCF of 4 and 24 would be 4. And then the GCF, we have v squared and v, so the GCF of that, remember, is just the smallest that I can take, or it's the most that I can take from either. The most I can take is the smallest, so v. All right, so I have 4v, and I'm going to factor that out. So 4v squared divided by 4v, well, that cancels. 4 divided by 4, and then 2 minus 1 gives me just 1, or just v to the first power. 1v is left over. Plus 24 divided by 4 is 6. V divided by phi also cancels out, and that equals 0. So now I have it factored. I can set each one equal to 0. So 4v equals 0, and I'm not color coding it anymore, and then v plus 6 equals 0. So now I'm going to divide by 4 on both sides. 4 divided by 4 cancels. 0 divided by 4 is just 0. That one's okay. That's not undefined. It's if we're dividing by 0, that's a problem. But 0 can be divided. So we get v, 6 minus 6 cancels, and I get negative 6. So I have 0, comma, negative 6. Alright, so that was section 5. I will see you in section 6.